new data set and how it was constructed. Zhu, feel free to take it away.
Yeah. Hi, my name is Zhu. I'd like to briefly present how we came up with this year's challenge dataset, which has an emphasis on fairness. This presentation is about this archive paper here, which was written in collaboration with many of the workshop organizers here, and also Google ML ethics team members. The paper is linked in the challenge website too. So let me start with introducing our baseline data set, Google Landmarks Dataset version 2, or GLDV2. This is the data set that was used in the past 2 challenges. It contains over 5 million images of over 200K landmarks. The images were downloaded from Wikimedia Commons. The dataset consists of train, index, and test datasets, and created to deal with the real-world instance-level recognition challenges that Andre mentioned before. It follows long-tail distributions. It contains hard matching problems, intra-class variability, and out-of-domain queries. The GLDV2 CVPR paper also presents detailed analysis of the data, where we can observe some bias. Most of the landmarks were in Europe, even though Europe is nowhere close to the majority of the world population, as you can see in the graph. The reason that this is happening is because the data collection was based on the Wikimedia images. In other words, crowdsourced. And the user distribution there does not follow the actual world population, as you can see in this map. As a result, more landmarks were added to the region where more contributors lived, and more training and evaluation images from those landmarks were added. Our fairness effort is related to the US founding spirit that all people are created equal, but our efforts to reduce the bias starts from the observation that not all landmarks are equally important. Let's say that we want to create a 1,000 landmark classifier. No one would oppose adding the Eiffel Tower to the dataset. However, many people may decide not to include the binoculars building, which is in fact my current office building, even though it is quite a landmark for the locals and designed by a renowned architect. Then, what is the justification of adding certain landmarks but not adding others? How do we determine how many images to add for these landmarks? It should be based on some kind of fairly defined importance or relevance, we call it, because we prefer to use the term relevance here because the term importance is highly subjective and harder to define. Each landmark has its own relevance. That's where we start from. So this is our goal. We want to estimate fair landmark relevance and use it for to enhance our data sets in terms of fairness. So the first thing we need to do is to define fair landmark relevance. One thing we found was that there is no single definition for this, but the definitions depend on the application or the use cases. For example, we could define a personal importance or utility by answering this question: which places are personally important or useful? Or for a tourism application, if everyone in the world can go anywhere in the world, what is the place they would like to go or remember? We have 2 observations here. First of all, these definitions are ideal definitions. We do not expect to compute the ideal fair relevance, but we are trying to estimate them with what's available. But we believe that it is still important to start from the ideal definitions and find what we can do from there. And the second thing is that these are all defined in terms of an individual person's relevance. So our goal is to estimate fair aggregation of this individual relevance. So how did we estimate this aggregated relevance? we use Google Maps user contribution statistics. For example, the number of photo uploads and comments. In fact, the crowd's contributions do reflect this relevance, and many previous work implicitly assume this when they just gathered any available images from the crowd data source. But as we mentioned earlier, there are some potential sources of bias, including internet or product accessibility and proficiency, the user's gender, age, place of living, the ability to travel, etc. So to reduce these biases, our idea is to use user demographics. Some of the contributing users' demographic information is available. For example, gender, age, or country of residence in many of these crowded source data sets. Using the demographic information of the uploader, we can balance out contributions from each demographic group using statistical stratification. We would like to note that the user demographic information is highly private information, and we went through reviews and procedures internally, very thorough reviews and procedures to use this information to compute the aggregated scores. Our efforts include setting a pretty high minimum aggregation level to protect the user demographics from being inferred from the result. So this is a formula we used. To get the ideal relevance, PC, the ideal class relevance, PC, we use marginal probability for each demographic group. We get the relevance. We get the relevance per demographic group, PC given age, from the Google Maps contribution statistics, and multiply that with the prior PH, which was obtained from the publicly available population statistics. Note that many of the previous data sets do not use this population statistics, but naively assume that the mined dataset's user representation follows the population distribution, which is not the case, as you can see from the previous internet user map. The distribution in this, so these are some of the distribution we got from the available statistics. And some other data sets like ImageNet, they assume that the class relevance here is the same for all classes, and as a result chose the same number of images for all classes, but they didn't explain how those classes were chosen. So please check our paper for details, and the actual equation is more complicated, and we are hoping to publish another paper with a full formulation. So this curve shows that our proposed stratification is effective. These are numbers of countries that contain top landmarks. For example, without the stratification, top 1,000 landmarks are from 62 countries, but we got landmarks from 77 countries when we apply the stratification. These are top 10 landmarks before and after the stratification. We see that Masjid al-Haram, the Great Mosque of Mecca, is now ranked at top 2. And we also see the Giza necropolis in top 10. When we see the top 5,000 landmarks, we can see that the results are more aligned with the actual population compared with GLDV2. So using these relevance scores we computed, we recreated the index and evaluation data sets for GLDV2. The index and evaluation data sets were sampled based on the relevance distribution. So as a result, they contain more images for more relevant landmarks while keeping long tail properties. Some of the underrepresented landmarks did not have enough images in the original data set, so we ended up downloading more images from the Wikimedia to fill up. So these are the example numbers of images in the data set. Giza necropolis is about a dozen times more relevant than Srikalahasti Temple or Veracruz Aquarium in Mexico. And as a result of random sampling, 20 images were chosen from the Giza necropolis, while none of the images were chosen for the Srikalahasti Temple, and 3 were chosen from the Veracruz Aquarium. This just showed that we applied random sampling, and then as a result of this random sampling, the long tails are preserved. We want to acknowledge that there are some room to improve, and we would like to be clear about the limitations of our data sets so that it is not misused or falsely trusted. So some of the potential sources of the bias, for example, internet proficiency, income level, ability to travel, they were not addressed directly, but they were only implicitly addressed through correlated variables, gender, age, and country. We may still not have enough landmarks in some of the underrepresented regions due to a lack of internet access or product users in the region. And relevance score may not be available for highly relevant landmarks due to various reasons, including the incompatibility between Google Maps and Wikimedia, or some lack of availability in Wikimedia. So once again, all the details are written in this archive paper, and we are hoping to come up with a full publication with more details. Finally, one of the future directions is to generalize this and apply this approach to generate instant level recognition problem or object recognition problem. Thank you very much. And I believe we have a little bit of time for question and answers.
Thank you, Zhu, for the nice talk. So yeah, anyone feel free to either unmute yourself or raise your hand via the Zoom feature under reactions in the menu, or you can type in your question as well.
I have 2 questions, Zhu. So the first one is why we sampling the data according to population is a good it's a good target. Why not other population? Why not other distribution? For example, area or like popularity of the thing or the regions, stuff like that. And the second question would be for the evaluation part. So basically, here, what I would expect it for a user is that according to different location or different area the user is living in. So basically, when he submit a query, we would expect to get different result. For example, if the user is living in Europe, so most likely we would like to recommend some Europe landmark. On the other side, if the people living in Asia, we'll give some like Asia results. So how can we use that information in our evaluation?
Okay, that's a very good questions and suggestions. The first question is like, why not area, like size of the area, but the populations? The reason that we use this was because our data source is the crowdsourced data sets. So we actually did consider the other options, like by just simply balancing based on the continent or the landmarks in the continents, but we decided that like what we wanted, like based on our definition of the fair landmarkiness, we want to come up with a fair user contribution. So that's a goal that we had. And then there are actually multiple ways of aggregating this. We are also considering some other ways of boost more diversity and other ways in the future work. But yeah, basically, because the dataset is crowdsourced dataset, we thought it would be the best way to to fulfill our goal to come up with a fair landmarkiness. And the second question or suggestion, I think that's a very good idea. And then I think it is also possible to come up with a ranking, landmark relevance ranking per each country. For example, we do have the data for that. So that could be one of the future work we can work on. But even within the country, depending on the gender or age, there are differences. And if you want to like come up with a system that really fit the user's need, like if you only return the result that belongs to the same demographic group, that might be one solution. But I don't think that's that's very I don't think that could be the best way to come up with a product, because like even though I don't live in Europe, maybe I still think that some European landmarks are very relevant to me. And yeah.
Cool. Thanks, Zhu, and thanks, Shu, for the question. So I think we're out of time, so let's move on. Maybe we can hand it over to Tobias. Zhu, if you can stop sharing your slides, please. I think Tobias will start sharing his.
Yep, just a minute.
Yeah, we cannot hear you, Tobias. I think you may have that little issue. Need to click. Yeah, there we go.
Can you hear me now? Okay, slides are okay. Good. Okay. Then yeah.
Yep.